All right, welcome everyone to this week's Xojo webinar. I'm Paul Lefevre, the Xojo Developer Evangelist, and this week we have special guest who's back for a second go-round, Justin Elliott, and he's going to be covering part 2 of Git. So Justin, the floor is yours.
Thank you, Paul. All right, so we'll go ahead and jump in with the advanced Git topics that I tried to cram into last session, but found out very quickly that there wasn't enough time because there's so much good Git content out there. So we'll go ahead and jump in. Today's presentation is going to cover advanced topics of Git. If you are looking for beginning of how to set up and initialize a repo, the basics of the workflows, you should go back to the YouTube channel for Xojo and watch part 1. So for today, we're going to jump into the advanced topics. So one of the things that I didn't cover, and I've taken some notes from the last session from Kem Tanekane, I always mess up his name, sorry Kem, and Paul, they gave me some good suggestions. I wanted to talk about reverting changes. Reverting changes, there are multiple ways of backing out your changes. So you can do a git reset, which resets the head pointer of your changes to a different commit. You can also check out a particular file that says, I've modified a file, but I want to revert or reset the file back to a previous state that it was at a particular commit in the repository. Then the last one actually changes the repository itself. The git revert function. So let's say you made a commit that's just bad. It's in the repo and you can't take it out because it's supposed to stay in the git repository history. Well, that's good. But you want to say, well, I really want to undo that last one. It was late at night. I was really tired and it just wasn't good. So you can actually recommit and undo those changes in the last commit that you made to the repository. And it will then return the state of the repository to the commit that was before that one. So in other words, you'll still have the bad commit in the history, but then you'll reset and reapply the changes back to the history so that it was at the state before that commit. It's hard to really talk about until I show it, so we can do that as well. So I thought also I would do more demos today in source tree. I know the command line junkies out there are probably, and I am one as well, but it was difficult to choose to do it all, more command line or source tree. So source tree, I think, is where most people are using and they're more comfortable. So that's why I chose to stick with it today. So apologies to the command line folks. We'll show a little bit, but it'll be mostly source tree doing. All right, so let's set a file in source tree. It's actually pretty straightforward to do. Notice the icon for source tree has changed. There is a new version. It's pretty slick. It's nice. So the UI will look a little different from part 1. So let's go into the previous project that we had. And we have some different tags. In this particular repository, just has one branch, master branch for now. We'll talk about multiple branches later in this presentation.
Justin, I'm going to interrupt you. I don't see source tree on the screen.
Okay.
You share the whole desktop or just the window maybe?
I will double check. Thanks for mentioning that. Let's see. Settings. Share new window. That's strange. All right. We'll try that. Is that working now?
Yes, I see it now.
All right. Thanks for catching me on that. Yep. I was hoping it would share the entire window, whatever's on that particular window, but maybe it's a Windows 10 thing. Okay. Thanks, Paul. All right. Going back to the project. So right now, this is the project as it is currently in the state of the repository. Everything's checked in. I have a git ignore file and a whole bunch of other changes. I'm going to open up my project. And I should mention quickly, in part 1, I was quitting out of Xojo. You don't actually have to quit out. A few folks pointed it out. Well, you don't really need to quit out of the application. That's true. You don't. You can just simply close it and then work on your commits to be safer if you want for open files. All right. So that button doesn't fit completely. Oh boy. So let's say I want to make some changes to here, and I've saved it. And it runs, and everything looks great. And I say, hello, world. And I say, oh, well, I need to run for the day. I've got some more work to do, but it's the end of the day. Well, now that I've changed that particular file, I'm like, well, I'm not really ready because there were some more things I want to do. So what you can simply do is just right-click the file, and in Git, you would type in git reset, or you could also check out the file. And in this case, I'm going to do a reset. And it says, are you sure you want to discard your changes in the selected file, which is the only one that's been changed. And the way I can verify what files have changed is in source tree to say pending. I could also say get status at the command line. So to reset it back, you would say reset to the last commit, or you can also do a reset to a particular commit. So I could say, well, I want the file as it was at the initial point. But for this demonstration, I just want to reset it back and put it back to the state that it was at the very top of the branch. And so now if I open up the project again, you'll see that the file still has the button. It's too small and it's not centered. So it has returned that file back to the previous state.
Justin, it definitely looks like you maybe need to do a share desktop rather than share the specific app, because when you're switching between apps, it doesn't seem to pick them up.
Okay. All right. Sorry about that, everybody. Let me check and see what's going on here. Share window. I'm seeing, look under settings. All right, Paul, I'm looking for the share desktop entirely because I agree that's what we should really be doing here instead.
Yeah, you should, on the toolbar at the bottom of the main window, there should be a share screen. It should pop up with I
see desktop 1, desktop 2, source tree, and source tree again, multiple windows. So that's...
Yeah, I think you just want desktop 1. Is that your main screen?
Desktop 1, we'll try that again. Okay, how's that?
All right, I see source tree and switch to something else.
Okay, we'll switch back to Keynote or Xojo. Keynote's probably better.
Yep, I see Keynote.
Is that working as well? All right, apologies, everybody. I can back up and show. Did you see the changes in Xojo with the file revert, or should I do that quickly?
We weren't able to see Xojo, no.
Okay, apologies on that. New recording system. Paul and I are, of course, I'm more me than him, getting used to it. So.
I warned Justin he was the tester for this. So.
Oh, I'm the tester. Oh, okay, that's my excuse.
Yeah,
that sounds good. I'll stick with that. All right, everybody. We'll do this quickly so we can move on. Yeah. So basically, right now, the current state of my working directory is that nothing has been modified. If I go to my working copy, I say what's pending, what's changed, nothing. So I'll say all files. Everything's green and checked in and up to date. I want to go back to Xojo. I want to resize this button, move it to the center. I'll save that. We can run it. Everybody can see that, of course, it works. Great. Okay, it looks good. It's centered and where it should be. Now, if I go back to source tree, I'll notice that that file has actually changed. Here's the locations, and I can see very explicitly what it did. Now, I think probably everybody could see the reset, where I can reset to the last version that it was in the very tip of that particular branch, which is what I'll want to do. But the other option we have is reset to a specific commit. So I could say revert it to the very beginning of time, or at any particular commit of where that, in the state that the file was at that time. But in this case, it's late in the day. I have more changes to make. I'm not ready to make that commit. So in this case, I'm just going to do a standard reset and reset that file back to the way that it was. So now if I go back to the project, open it up in Xojo, you'll see once again the button's not centered and it's not widened to fit the entire text. Something to note in source tree is a lot of people are saying, well, what did it really do behind the scenes? Something to mention, what's very handy at the bottom is under the command history button, you can see what it did. Here's the full command that source tree did. It uses a bunch of different arguments. But it's interesting to see they call it checkout in the UI, but yet they're doing a checkout of that particular file in the command line. So that's just something to be aware of. That you'll see there is a get reset term and a get checkout there, slightly different, and those are ones that you'll want to review more of on the Git documentation site. All right, so that's how we basically do a step file. And you can do multiples at a time. You could also just reset and check out a particular commit, and it could blow away and lose all of your changes, and it'll tell you multiple times, are you sure you want to do this? You'll lose your changes. Later in the presentation, we'll talk about another feature that allows you to temporarily save them off to the side and revert and test and then restore those back without committing to the repository. It's very handy. All right, so next, and actually it's up next. Stashing changes. So stashing changes, look at the big pretty slide on screen. The stashing changes are I thought later, but they're actually exactly what I was wanting to talk about next. It makes sense. A good segue. This is when, so a stash is a method in Git that allows you to take the current changes you have and store them temporarily in what is called basically just a stash. The stash is local to the machine that you're working on. It does not actually store it as a commit in the repository, and it's basically a way to temporarily move files out of the way, test something, move to a different branch, and then put them back. The ways I've used stashes, let's say you're working on something, you're not quite sure, you forgot about some particular change that you made, you want to make sure that the bug was there or the feature was not there, you want to return your working files back to a known state, but you don't want to lose all your work. That's where you create a stash and then revert back, test those changes, look at the code, and you can then reapply the stash that then changes the files back to where you were, so you can continue and then do a commit of those changes. So let's go ahead and jump it back into SourceTree for that demo. We'll go back to Migrate App, and we'll go back to all files, open up the project, and now this time I actually want to make this button fix permanent and say, okay, now I saved it. All right, but I don't want to commit it just yet. I'm going to close that. Xojo's still running, but the application documents have been closed. Now I say pending. I said, well, there's something else I want to do here, but I'm not ready to make this commit. What you can do is, it's either here, maybe I didn't add it to the menu bar. I'm looking to see if stash is an option. No, it's not. All right. I can stash the changes to the repository. So it stashes it in the repository, but it's not a commit, so they are different. So I could say, you can call this whatever you want, but typically it's a good way to leave the stash, have the stash titled with something that you'll remember. So you can say, centered, button, and resized. Now you can say keep state changes, or if I click OK, it's going to store them in the stash and then delete them and revert the file back the way it was. Okay, so now it shows on inside of SourceTree. It says, okay, I know about some stashes, and here are the changes that you have. But I've now reverted my local file set back to the way that it was, so that the button is still, not widened or resized and not centered. And say, okay, all right, I remember what I'm doing now. Okay, so now I want to actually replay or apply that stash back to my local files. And then I want to delete it. I would recommend doing that as a workflow, because otherwise stashes are really meant for temporary file changes. And there's some schools of thought about branches, if you should delete them or not. Git folks generally recommend deleting them so they don't hang around for a long time, because they're really meant for temporary use. All right, so now we're going to say, okay, so it deletes the stash and it reapplies those changes back to the file that I had made. So you can see that on the diff, it shows the left and the resizing of it and the centering as well. So if we open it up, we can see that running it, you can see already, but it's, centered and widened as well. Then what you do is, okay, now that let's say you're happy with it, you could actually do the commit at this time, stage it, and you could say resize the button and centered it. So stash is really useful to move something temporary out of the way, switch to another branch or another commit, look at the code there, copy it, revert back, finish the changes you made, and then apply the final commit. So it's pretty useful for a temporary move of files. All right. So that's stash. All right. So you probably saw. So moving on to the next topic, which are tags. Tags are basically extremely useful for bookmarking a particular commit. So some tags that are used are for major version numbers. So you could say, Paul, can you go check out this project, look for tag ID number or bug report number or whatever, or feedback case number. So you can label the tags with the useful information as far as a version number or a bug report. Sometimes people use branches actually for bug reports, more so for that. But anyway, it's basically to tag or bookmark a particular commit so that it can be used and referred to very easily. Naming convention, of course, you should follow. Don't use spaces, no white space allowed. If you have subversion repositories, which I did, I had a lot of tags in those that had spaces in the tags, and they all got converted to %20s. And so that's, of course, that's annoying. In that case, all you need to do is you can clone the tags, copy them, and then delete the old one, and you're good to go. Now, in my case, because that was an old subversion repository, it had quite a few tags. So it can take time. But with tags, if you do that, remember to always push the tags to the remote when you use a remote host, and also delete them as well, because otherwise you'll see weird behavior where you deleted the tags locally, but they still reside on the remote, and then when you do a pull, it restores all of those tags back again. Yes, you can tell I'm speaking from personal experience, and that was frustrating when I had over 200 tags. So anyway, so let's go ahead and jump into a quick tag demo. All right, let's go back to the Migrate app. And so it's actually pretty straightforward. It's very easy to do in SourceTree as well, and we can look at the command in the command summary at the bottom. So let's say, okay, we're going to call this particular commit in the history. We're going to call this one, we'll call it version 1.5 dash. I like to label it with the version of Xojo that I'm using, 2014, and I think I'm still at R2.1. Yep, R2.1. This is where you can also put in additional. Well, I'm jumping ahead. We'll just leave it that way. All right. So tag could label the version, and then it's a useful reference on the side, and you can check it out very quickly. Where I was going, because I think I should mention it. I think it's in the slide. Let's say you're using Monkey Bread software plugins. You could do 14.1. If you're running on OS 10, tags can be very long and verbose. They don't have to be, but make them useful to whatever works for you. Now, it should actually say working copy parent. If I did specific commit, you can go back in the history, but I want to do working copy parent and say add. And now it will show that, okay, if I have a tag here of 1.5, I can quickly, instead of having to go through after your repository gets very large, you'll have hundreds and hundreds of commits, right? It could be very difficult to find out at what commit were we at version 1.5. That's where tags come in handy. You could say, okay, I want to go back to and check out version 1.5 of this particular repository. Now this is where it'll warn you, and it says, okay, you're going to have a detached head. Basically that means, and there's a slide for this as well later in the presentation, but this is useful. Git's just trying to tell you, hey, when you check this out, the head pointer, the current status of your local files, is not going to be at the latest commit of your current branch. And that's okay. It's just letting you know if you're making commits, you want to make sure you check out the latest version and then apply those commits. Or create a branch and then edit those changes and merge them back. So, but the better demo would have been to check out version 1.0. Check out, and then check out that version. All right, now it shows and says, hey, I've got some changes. Okay. Now I've checked out version 1.0. But a new file shows up in the local because there were some other git ignore files later that said to ignore additional files. So tags are a great way, like I said, to mark and bookmark a particular commit. But let's go back to and check out the master button, or master commit, I mean, and return it back to the state that we know we want it in. All right. All right, so tags are useful for bookmarking commits. Now the branches. Okay, so branches are is where Git excels. Branches are extremely useful for separating your development into different codes changes. Typically, a branch is always representing the very latest commit in a line of it represents the tip of a series of commits, which means it's always the last one. And that's where detached head says I'm checking out something that is before the last commit. But basically, branches are just pointers to commits. That's all that they are. And so is the head. It's a head reference. It's a pointer. But a branch is also not a container for all those commits because Git on the back end is storing each commit as a complete hashed item. And when you create a commit, it says, okay, this particular hash was committed to this particular branch. So it's definitely just a pointer to a particular commit. It's something to remember. Now, the standards in Git branches in Git can be called anything, but the de facto one is master, which is the default. And when you're starting out in Git, that's the one that you're working in. Later down the road, that's the branch that you don't actually want to develop on, as people recommend, but that's the one you want to always merge to. And the thought is, is that the master branch should always be considered the branch that anybody, when they go to the repository, can check out, and they can assume that that is the version of your code that is released in the public. So you could say, I need to make sure I get the latest version. Justin's out of the office. Well, if he's a good boy, he'll make sure that the master branch is always the safe one to deploy, and the other branches are always deployment and off, not either being tested or otherwise, or in pre-release testing. So where I'm going next with this is, in 2010, there was a gentleman who created GitFlow, which is basically an interesting model for branching model. It has multiple branches. I'll admit I don't use all of these. If you search for GitFlow, you'll see he's got a fantastic PDF of it that explains the layout. And basically you have master and a hotfix, develop and feature and release. And so I tend to use the master, of course, hotfix and develop. I don't use the feature and release too often, but they are very handy. And I think I still may have the PDF. So we'll show very close. We'll take a chance on making sure the internet's working for me today. And so basically, if you look under, I forget, Vincent Dreisen, I hope I'm saying his name correctly. Apologies if I'm not, if he's listening. I'm sure he's a Xojo user, of course, right? But you'll see here, so basically you have a master branch, and then you create what are called, and then you branch off to a hotfix in case there's a quick fix to make, and commit it back and merge it back to the master. But anyway, GitFlow is highly, highly recommended. I use a form of it. I know most people do some form of it or some type because they find it an effective way to go or to manage the projects. For the command line folks, it's just a basic git checkout master, checks out the master. Of course, the master, replace that with a branch name. Or if you want to create a new one, -B to create it and switch to it. And to delete branches, you could do a -D, which will confirm. If you do a -D, it won't confirm it, and it'll assume you know what you're doing, and you can actually delete the branch without prompting you. So be careful with that command. All right, so the visual for branch walkthroughs. All right, so this is going to assume the master branch, and we're going to start with the first commit of M1. So of course we have the first commit and branch. And so a good practice is, of course, to always branch from the master. We would create a new branch that's called B1 in this case. That's where you'd make some changes. You'd make a commit. Now that B1 commit is on the branch, the separate branch, and it's not placed on the master branch. And I'll show this as using a hotfix branch later in the presentation here. Then you make another change to that particular branch. If you're doing, on your develop, you make a third. You continue working there until you're happy. And on the fourth commit, in this case, you're saying, okay, we're finally ready to push this and merge this back to the master branch. Well, then you do that, you merge, and then when you merge back to the master branch, you'll know that M2 is another safe spot where folks can go to the repository and check it out. If they wanted to, during your development cycle, they could also go to the repository and check out your branch if you pushed it to the remote. And they could say, hey, Paul, I'd like you to check out this branch. It's not on the master branch yet. Can you go look at this and test it and see if it works for you? Yep. Or no, and it works or doesn't work. Once it's good to go, then the person who owns it should be the one who merges it back, and then the old branch gets deleted. Typically in Git, branches are deleted. Mercurial, I know, and others, Bazaar, and other source code repositories or systems, in some cases, keep the branches around forever. Git, like I mentioned earlier, typically folks delete branches so that they're not left hanging around. It could cause confusion later. So detached head reference, we saw this happen a couple of times, but it is related to branching and changing the commits, and so it's very much related to this, so that's why it's placed here. Again, head is just a reference to the latest commit on a branch or a specific commit. I'm reading to make sure, I think I've mentioned these as well, but Git keeps track of that head pointer and either points to the latest commit in a branch or, again, a specific commit. And yes, the third point is basically trying to say that whenever you're doing code changes, you should always be on the latest branch commit, the tip of it. And you don't want to make any changes that you want to recommit back when you're in a detached head state. Because otherwise, your only option then if you do that is you have to make a new branch. You can't recommit back to that branch, and you have to make a new one, make your changes, and then merge them back in. So you make a little work for yourself if you end up doing that. So detached head is just something to be aware of. It's nothing scary. Of course, when I first saw it for a long time, I thought, well, why do I care? Well, this is why you care. It's not a big deal. It's just letting you know. Don't make development changes on it unless you do a branch, or you revert back and then you can make your changes at that point. All right. So let's break down the GitFlow a little bit. I'm not going to go through all the steps because there are a lot of them here, but I'll just do the basic one. So again, workflow is a successful Git branching model. The main premise of it is you basically only want to branch from it and merge back to the master branch. You never want to develop on the master branch. Now, some of you may be doing that already today, and that's fine. That's fine. I was doing that for a long time too. When you're ready to do branches, though, get used to the fact that you'll be always developing on the development branch or another branch, which is perfectly fine. So the different branches that it has is master, main one always, that's production, a hotfix, which is what you would use for, you have version 1.0 out the door, you're working on 1.5, and all of a sudden the customer reports an error in version 1.0. That's where you could, from the master branch, make a new hotfix branch for version 101, apply your change, and merge it back to develop and the master, and so that you don't have regression, and the master branch is then up to date with what's in the public. I know that's a lot. I'll show a demo here in just a second. And the bottom URL is again the one that I brought up in the website, but with the day and age of Google and everything else, you should be able to find it. But that's the URL should you want to look and write that down or watch the video later for it. All right, so GitFlow. All right, so it's very similar to branching. I mean, it's very, this is going to be a hotfix commit, but they're meant to be very short-lived, not very long. So let's say we have our first commit, make a second one, third, then a customer reports an error. And this is where you would say, okay, I'm going to make this a new branch, make that change, and I'm going to immediately merge it back to the main master branch in that case. You can see it's very similar to standard branching, and it is. The GitFlow model can get very intense, though, because the hotfix in this case does not show when it merges back to the C3. It would also be merging back to the development branch. But for simplicity, I left it at this rate because it was simpler to explain. Then you could continue on doing your fourth commit to the particular branch. So I think we can do. We're going to attempt. This might be. All right, so now in source tree, to do a GitFlow, this repository may or may not have been initialized for GitFlow. So it's nice that source tree, by the way, has GitFlow built in. They've adopted it, many have. The documentation for GitFlow is exceptional, so I would highly recommend reading that. But I'm going to initialize the repository, and you need to do this because it changes the defaults for this particular repository. Now, for everybody who's using the same repository, be sure that everybody does the initialize repository because it changes the local settings of these particular names and sets up the configurations and settings needed for GitFlow to function correctly on the repository. I always use the defaults. It's easier to not change those around. I would recommend not changing those, but you can. But it's easier also if you're reading documentation. It just reiterates what you read. All right, so click OK. So it didn't actually change anything in the repository. But now notice my branches. I'm no longer on master branch. I'm now on the development branch, and that's your default again. Let's all of a sudden say, customer reports an issue with our particular application. Well, this is where I would say, okay, I need to start a new hotfix. And now this is taking, now the hard thing to note here, now hotfix is going to take, it's going to start at the latest master branch. Notice how it's grayed out, and that's by design. Hotfixes are not meant to change one of the development branches. They're only intended to change the master branch that you're working on. And I'll just make up a number. So let's say I have a bug report 01, and I could even call it, I could say fix bug report 01, whatever naming convention you want to use there. Now it says, okay, now I'm working on this particular branch, a hotfix. I go back to my files. I'm going to open up the project. And let's say that we want this button to be a lot, I don't know, we could move it up to the bottom. Let's move it to the bottom, sure. And I know for demonstration purposes this is not very exciting, but of course it's just meant to show the concept rather than show how to code. All right, so we'll run that. Yeah, it works. Okay, great. All right, yay, that's the hotfix. The customer didn't want the button there, they wanted it at the bottom. Whoops. All right, that's been fixed. I'll close that file. And now I can say I want to finish that particular hotfix. You could tag it if you want, and it's going to delete it immediately. I would do that. In this case, we do not have a remote configured yet. And I'll say fixed button position if I could type. There we go. And now, okay, unstaged changes. Oh, that's interesting. Well, let's take a look. Let's see what it is. I'm going to go to the terminal. This will be fun. So I'll say get status. It's been modified. Ah, you have to stage the files first. There's nothing to commit. I can't finish the repository of the hotfix until I commit the changes, right? I did that on purpose for the demo here, I'm sure. Right. Okay, repositioned button. Now, and that was right, it was good to show me that that was the error. And now I can see in that particular branch, the hotfix branch, reposition the button, made that commit. Now you can go to the GitFlow and finish the hotfix. And I'll tag it again, and I'll say repositioned button. Now it's going to actually tag it, delete it, and it's nice that Git always tells you that it always errs on the side of not losing your data. So even though I made that mistake, it's good to reiterate that it's there to protect your local changes. All right, now it's been committed. Now it's good to go. And now you're looking at, whoa, what just happened here? If you look at the graph, you'll see that, okay, we were on the master branch, and we made a change, and then we merged that change to the master branch, and then merged it back again to the develop. And so now the development branch hasn't lost the change. It received it as well as the master branch, so you didn't lose the change. So now if I go back to master branch, I check that out, and I open up the files. Sorry, excuse me. It'll say merge, and it says merge branch into develop, and then it also says into the master branch as well, and I can see what was done there. So the hotfix was basically applied to the master branch and the development branch, and so I can continue going back on, continuing, and I didn't have regression and lose a particular hotfix, which is very handy. All right. And again, like I said, there's a lot about branching model. It's something that's one of the things that kind of takes a while to get used to, but once you get used to it, you'll end up loving it. It's been very liberating for me. And like I said, I live on the master branch. I live on the development branch, push and merge back to master, and I use hotfixes all the time. So, all right, let's move on to remotes. Okay, so. All right, so now we've got branching under our belts. Now the next thing is remotes are pushing to a centralized server. Currently in the part one, and so far in this one, we've only been working locally on the computer that I'm on. So if you've got a backup system, that's great. You're backing your local machine up, and that's good. However, that's not great for collaboration. And remotes allow you to collaborate and push your code to and pull changes from a hosting service. So Git by default, of course, allows you to create local repositories, but that's not going to help you with collaboration and getting your code out in the world, such as GitHub and other hosting services. So the remote, of course, allows you to clone, copy down, push, update, and fetch, see what it's done, what it's changed on the server side, and pull to update your local copy to match the repository that's on the remote host. The workflow is basically on your local working directory. You would stage those files, you push it to the repository, and now the orange box represents when you now add a remote to the mix. The dotted line going down means you push, and then the dotted line going back up to repository means you pull. So you're updating your local repository of changes that others made and pushed to the repository. So that, Paul's making changes. Hey, Justin, I pushed them up to the remote. You might as well do a fetch, see what's changed, and if you're happy, then do the pull to make a change to your local files. So It's a very easy workflow, and it has worked really well with my team of 4. We have quite a few repositories internal, so it's worked very well in testing and collaboration. The remote repos can be accessed via many different protocols. You can use SSH keys. It's very handy for that. You can use separate SSH keys for different services. Some people like that. I use it for some services. Over HTTPS, but of course both of those are secure, which is highly, highly recommended. Or you can also use the Git protocol, daemon. Most people don't do that. It's more of a headache to set up. So most people stick with SSH and HTTPS. You can also host it yourself. Pardon me while I get a drink of water. And SSH actually is super easy to set up and enable on OS X and other clients. And it's dead simple to have it set up as a separate repository, a hosting remote. In fact, I've done this. I've got some repositories that I have here at work. And I've got some pushed to our internal team repository here, or our server rather. When I go home, if for some reason my internet connection to the world is down, or our server at work is has maintenance going on, I have multiple remotes so that I can then push to my home server via SSH. And then when I get to work, if I want to update, I can connect to my home machine, update from there, and then push it back to our remotes, or server-based. I'm sorry, my work-based server. So in other words, you can have multiple remotes. Most people just generally probably have one, but you can have multiple. And you think, oh my gosh, that's a recipe for disaster. Well, it can be if you don't have an agreed upon way of working with the rest of the team. But I'd recommend in that case to make sure you always have a single understood, hey, this is our particular master repository server. In my team, we do that actually. We have our internal server is the master repository, but some of our code is safe to push to GitHub and others that we've sanitized for security purposes. Those would be our secondary remotes, so that we push to our primary, our internal one, and then we push to the other ones as we get time. So multiple remotes, very handy, very useful. Different third-party remote services. I'm not going to go through all of these. I'm sure there are a boatload of them out there, but of course GitHub, Bitbucket are my 2 favorites. There are other out there that are quite good as well. So these are third-party. These are not ones you host yourself necessarily, but if the third-party service works, I'd go that route. Bitbucket is extremely handy for up to 5 people. Actually, you can get it up to 8 with private repos for a team. Very handy, free, unlimited repos. Highly recommended. All right. So the terms you've heard about remotes, cloning a repository, and this means that you're basically, this means that you're basically copying down the entire Git repository to your local computer. It includes the entire history of the changes, commit messages, branches as well if you check out a particular branch. There's the syntax at the bottom there where you say git clone, a particular URL to the server. You'd enter in your credentials and you're good to go at that point. Source tree makes this very easy to do. Then pushing is different than doing a commit. So on your local repository, what we've demonstrated so far is basically doing a commit to the local repository only. Pushing actually then says, okay, all the changes we've made locally, push those up and save them, commit them to the remote repository so that others see those changes. So pushing is, in this syntax at the top, it says get push my changes to the origin. Origin is the name of the particular host. That's the Git convention, or they've named origin as the remote host instead of having to use the fully qualified domain name. Origin is the default name for the default remote host. I'd recommend sticking with that name. Don't change it from origin to something else, even though it would make sense maybe for readability. You'll get used to understanding, origin, that means the master server, the master repository server remote that I'm using. I renamed it at one time, and source tree, and what happened is some source tree, other Git GUI clients like source tree assumed it was at origin. It wasn't, and I had to do a little bit more work to push, so leave that one as origin. Now you can rename additional remotes whatever you want, and in fact I did that for my home server. I call it Elliott Home SSH Git server or something like that. So, but leave the default one, recommended. Leaving it at origin is the best way to go. Something to be aware of Git 2.0, version 2.0. Git 2.0 is actually out already, but source tree and others haven't updated it to using it yet, and that's okay. But the behavior of pushing branches has changed. Previously, what Git was doing is, and this is okay, but people felt it was a little unsafe. If you did a Git push, it would push all of the same branches that you have, even the branches that you're not currently active on. And what that could do is, let's say you made some changes to a local branch and you forgot about it, and then you switched back to another branch and you only wanted to change, or rather push the changes of the current branch that you're on. So they felt it would be safer, instead of pushing all of the matching branches, to change and push by default the branch that you're on currently. You can override that behavior and say to push all matching if you want to, and it's easy to do that, but it's there as a safety feature. So if you're at the command line and you do a Git push and you see that, it's nothing to be worried about, just something to be aware of with the change in Git 2.0. All right, fetching. So fetching basically says, okay, the remote server, Paul's made some for example, Paul made some changes to the remote repository. Well, I want to see what he's changed, but I don't want to change my local files yet, just because I'm in the middle of something. So what you can do is I say, well, unlike Subversion where you have to have a connection to the network all the time, Git doesn't need that until you tell it. And so fetch says to Git, hey, go and download the current state of the remote repository and tell me what it all has. Don't change my local files, just update all of the references that you know about that it has, as far as commits, branches, tags, things like that. And it's useful to always get a fetch, not always, but if you have no local file changes, you don't need to do a fetch. You can just do a straight up Git pull origin, and master the branch name. If you're not sure and you don't want to lose your changes, fetching actually is a much safer way to go, because it says, I don't want to change files. Let's say you have a production server that's using Git, and you fetch and update your files, then you get the updated changes there. And then when you're ready, then you do a pull, and it will actually modify the local files. Remote demos. We have 15 minutes, Paul. Yes, I'm aware of the time. Too many slides again. I really tried, I promise. All right, so we're going to jump in. We're going to put create a repo, add it to the local repo settings. And then my phone is buzzing. Sorry. And then we'll push committing locally, and then we'll show that process. Okay. And something to note, all local branches and stashes are never pushed to a remote. So those are some things about that. So let's go ahead and jump in. And I'm going to, I could get to bisect, but that's all right. That would be cool, though, if we can do it. All right. Currently, right now, this repository doesn't have a remote, and I've got everything is local, so I have no remotes, which is sad, right? I don't like that. So I'm trying to repository settings, remotes. There we go. I can say add, and it's going to be. I remove my Bitbucket account. There it is. All right. And so I can say, why is it not showing me create new repository? I think I want to, I'd rather push it up to the empty one as well. I'd rather do that. I think it wants me to, yeah, no apologies everyone. Let's do this. I will go through I'll say create a new repository. Just repo, private repository, allowing us to get language, HipChat, sure, great, yeah, good to go. And I have an existing project, and I can do these commands at but I can now get the URL. So instead of having to do this, I can say, grab this URL, and I'm cheating here a little bit, I admit. You can go to the command line and do this, or in source tree, and I'll say repository settings. I'll say add. Nope, sorry. Bitbucket test. And now it understands, okay, you're using Bitbucket. I've got your username. I've got your credentials already. And I'll say, okay. And now the remote, it's here. And I haven't pushed anything yet. So if I go back to J. Elliott test account and I see test repo, nothing is here. So it's empty. Let's go back to source tree, and I'll say local changes are clean. And I will say I want to push Bitbucket. And now what do you want to do? I want to, in this case, I want to push and track, which means I want to create new branches on the remote, and I want those branches to track what I'm doing locally. So I'm going to also push all tags because I like everything to be up in the repository. I'll click OK. And I'll say I'll allow for my keychain access for the password. And now the Bitbucket has those two different branches on it. Go back to Bitbucket, I refresh the page, and now there's no README. Okay, that's fine. And I can see test repository, and I see the commits. So I'm looking for, there we go, the different branches. You can see there's develop. Then I can show different, it's been off of the master. I can look at the commit history and all of that. So now it's up on Bitbucket, and others could share it and download it from there. All right. If I go to terminal, and I do a more on git config, I should see, well, there's GitFlow stuff that got initialized, and there's the entry for the remote. There's the URL, and there's some other things that it needs to do its job. So you can see things have been changed by GitFlow and the remote edition. All right, so local branches and stashes. Yep, so local branches. So if I create a new branch, you don't necessarily have to push it up. So if I said push, I could actually uncheck something and say, I only want this to be a local branch. And a lot of people work that way, which is why Git is really, really cool. You can do local branching. If it doesn't work out, you throw the branch away, no harm done. But if it works, you push it up, have people test it, and then you can, save your vanity and not be embarrassed. If you had a great coding experience, hey, great, caffeine was good. Or if it didn't work out, then of course not. I know this is fast, but it's great that it's recorded, which Paul reminded me. People can actually review it. So I'm going to risk it and push on through to the Git bisect debugging tool. All right, so with Git, there are some useful ways also to help you narrow down a particular commit where a bug was introduced. And this was very, very, very helpful to me at one time. I had some software that I developed some system imaging software for OS X. And I found out after the fact that 2 versions ago, in between the version 3.16 and 3.17, I had introduced a bug. And I didn't know about it. And I was testing 3.17, and I said, wait a minute, when did this bug happen? And I tested and reverted back to 3.16, and it worked fine. The bug was not there. And I thought, oh, great. I've got 200 commits. How am I going to, I could go back and change the commit to each and every single commit, but that takes a lot of time. Well, Git has a binary search that does that for you, but does it really fast and elegantly. And it's called the Git bisect function. Git blame is useful to show, I should mention, of who changed what line in code. So you can have fun and give them the dunce of the day hat and say, oh, you broke the code, go fix it. So if a particular line of code broke, you can actually have Git tell you who last changed this line of code and then follow that history. But we're going to focus on Git bisect at the command line. Now this is where knowing the command line is helpful because this is currently not available in source tree to my knowledge. They didn't have it in version 1.9.8. I don't think it's in version 2 either. So let's show you how that works. We've got a project already, and here's the Git bisect bug demo. All right. Now, with Git bisect, it's helpful to use tags. So I have 2 different versions, version 1.0 and 2.0. They're very clean. I kept them short because it was just easier for the demonstration. All right. So I've got a basic math calculator, and it's got some problems. Intentionally, of course. I never make buggy code, of course, ever. Yeah, right. Let's go to all files and open up the project. And we'll run that. And you can see, okay. All right, so I'm going to add some numbers here. 1 plus 1 plus 1. That should be 4. Oh, wait, what? When did that happen? When did that break? Oh, great. I don't remember. I didn't do that recently. I was working on this part. Okay, well, all right, let's quit out of that, and I have no idea where that could be. So I'd say, okay, fine. Well, I'm going to check out version 1.0. Yes, detached head. Yes, we're aware of that. Okay, and now it says head pointers here. Now the file states locally, all right, what they were, version 1.0. We'll go back to working copy, open up the project, and run that. Obviously, it's a very basic app. I'll say 1 + 1, 2. That works. So something broke between version 1.0 and 2.0. All right, I'll close that. Okay, so now I want to say, well, I want to check out, go back to the master. What you do is you break into the terminal. Where's the terminal? Thank you. Yeah. All right, let's close those. And I'll say, now, the nice integration with source trees, it dumps you in directly to the directory where the project is at. So it's kind of a nice integration point there. I'm going to say git bisect start. Okay, it says, all right, you're starting bisect. All right, now I need to tell it by typing git bisect bad, what that means is, unless I supply a tag name here, which I'm not going to right now, it's assuming that I'm talking about the current location of where the head pointer is, which is at the latest version of the master branch. So I'll say bad. All right. Now I know, because I've already tested it, I can say good, and this is where tags are extremely helpful. Otherwise, you have to type in the very long commit ID, this whole long thing that's actually longer than that, longer than 26CF, that whole thing. Because now I know this is where tags are extremely handy. So I'm going to say, okay, so the version was good, was at version 1.0, and the bad was on where the current pointer is of the repository. Okay, it says, all right, it's doing a binary search. Now what it's done is bisect has changed the head pointer from the master point, and it's saying, okay, well, let's keep going half and half and half, and I'll narrow it down for you. It's basically just doing a binary search, but you can see how effective and how much time this would save you if you're looking at thousands of commits. It can help you narrow it down very quickly. All right, so now what it says is, okay, I've changed it to a commit. Go and test your application. So we'll do that. So we'll open up project, and I'll say, okay, is there a problem here? 1 + 1 + 1 + 1. Make it as easy as, oh, wait, whoa, that's really wrong. Okay, so it's still bad. So I'll say, okay, get that that particular, where we're at right now, is bad. It says, okay, I've got 0 revisions left to try, and then roughly one more step after this. So let's go back to and have it show us, okay, now it moved it down by 1. And go away, keychain. All right, so let's go back to the repository and say, all right, let's see if the problem is still there. Yes, I've changed the windows. And we'll do this and say add them up. That's still wrong. Well, okay, well, something's still broken. Where am I broken here? It turns out I have multiple bugs in here unintentionally. Still bad. It says, okay. And now it's changed the master. It's now moved the head pointer 1 more. And now it says, okay, now check it out one more time. Let's see what's going on. Version 1.0 was good, so guess what? It's probably got to be this commit, right? Because we'll got to run it first. 1 + 1, 2. All right, that's clearly broken. All right, so now if I close it and I jump back to, the terminal, I'll say it was still bad. Now it says, okay, here's the first commit with this long ID of that was bad. So what you can do is you can actually do a commit and you can do a checkout. Hash numbers you shouldn't have to remember. You can if you want to use them. But the way you can do it in this case is, go look for the commit that was 12/14/01, which is today. Got that close. Was actually the one that we're at right now. So here it is. So we can see that the commit number at the beginning is D96-3F62. Go back to the terminal. D96-3F62. That's it. So that is the one that I actually started with that has a problem. And then I can say, all right, show me the differences. Let's see what's in here. And my external view editor is not working at this point, but I'll try it one more time to see if it says. But yeah, file merge should be opening right now, but it's broken for some reason. But source tree's built-in diff engine is pretty good. So that what you can do is you can break it down further, and this then reiterates using tags is extremely helpful for things like git bisect, and breaking out your commits into smaller commits helps out a lot, especially when you want to use advanced features like git bisect to help you find which commit is actually the one where the bug was introduced. So this was not a really exciting example because I don't have hundreds of commits, but I think you probably got the general idea. Broken between here and here, which the commits was it? Well, here's the first one where it broke. Yeah. So it's a pretty handy function. So I'm going to type get bisect reset because we're no longer bisecting. I'll solve it again since we're not bisecting. All right, good. Now it's clean. So bisect actually, like I said, helped me big time in a particular project, helped to narrow down. You could still do the functionality that it's doing by yourself, but it would take you a lot more time. So it's a matter of convenience. All right, so let's go ahead and jump into lessons learned. We got just over 2 minutes left. All right, so I highly recommend learning the basics of the command line. You can see that you can get more advanced features. The other nice thing is occasionally SourceTree and other tools will throw up the wrong error message. And you're thinking, that can't be right. Or it might be the right error message, but if you go to the command line and you do a get status to try to run the same function, you might get better error output, which will help you diagnose the problem if there is one. I've not had many of those, but it's been useful now and then. So those 2 points are something to keep in mind for the command line as well. And embracing branches, definitely a huge benefit of using Git and source code management tools in general. Be sure to initialize your projects for GitFlow. It'll make some changes to the repository. And stick with the easy things such as developing HOTFIX branches to start. And these are all very easy to do in SourceTree. It keeps getting better and better. The new UI is they've improved it quite a bit. Very strong support. The same folks who develop SourceTree also run the Bitbucket, the hosting repository site as well, which is extremely good. So, and it's so far free to use those 2 things. So it's pretty impressive. So, we're out of time. For more information, make sure you check out the official Git site. They have excellent Git cheat sheets there. They have a fantastic Git Pro book, which is a PDF. It's huge. It's very fun to read on a Friday night. Oh, yeah. And then there's some different try sites. You can find this, of course, through Google, but Atlassian is a huge believer in Git, and they have lots of documentation on Git Flow and all of the different Git methodologies. They also moved a huge amount of Subversion repositories to Git. So if you're interested in their process and their take-home learned lessons, go ahead and check that out. And then O'Reilly, of course, is always a good source for mastering Git content. And the one that McCullough and Berglund, I actually have the videos from that. It's excellent. It's really, really good. All right. I think hopefully I left a little bit of time for Q&A. Paul, I realized we should have broke for some Q&A, so we can do some now if you want, or if we're out of time, that's fine too.
Well, I've been monitoring the questions, and actually I haven't seen any, so I don't have any Q&A.
Well, that's sad. Oh, somebody's got to have a question.
So I don't know. The only questions were at the beginning when people weren't able to see your screen properly.
Okay. Well, we fixed that question, I guess.
Yeah, we certainly did.
All right. Okay. Well, thank you, everybody. If you do have any questions, feel free to email me at that email address, and I'm on Twitter, so feel free to reach out, and I'll help out where I can.
All right. Well, thank you very much, Justin. This was an excellent webinar. I really like that stash feature. I think that is going to be pretty handy.
Yeah, it is quite useful.
I did not know about that, so that's pretty nice.
Yeah, it's a pretty handy feature. I've used it a couple of times where I'm so tired. I don't want to work on this anymore. Stash it, come back to it tomorrow. Okay.
Yeah, I can see a lot of uses for that.
Yep. Revert, put it back when you're done. Yep, it's really handy.
All right. Well, I want to thank Justin and thank everyone for attending, and have a great day.
Thanks, Paul.